In order to graph parametric functions on our calculator, we need to change the mode. So if you go to the mode button, you'll notice there is something called parametric down in with the functions. So let's scroll down and then scroll over, select parametric. And now when we go to y is equal to, we notice that the menu in fact is very different. So I'm going to graph this example. So we have 3t minus 4. So I'm going to do 3, and when I press the X button, notice this comes out as a t now. So 3t minus 4, and our y is going to be 1 minus 2t. And I am given a restriction on t values. So now I need to go to the window as well. Window looks very different. So our t min in this case is 0, and we are given a t min for this problem of 3. I'm going to leave the x min and x max, and I might have to adjust that. But we'll see what this looks like. And let's take a look at the graph. So as you would have expected, this is going to give us part of a line. Let's explore this a little bit further. For starters, when you have a parametric equation, system of equations, you know that there is always a direction to this. So in order for me to see the direction, I kind of know what it is because I know that x must be increasing and y must be decreasing. So I know that this needs to go left to right and top to bottom. But in order to actually visualize this, I can slow the graphing down by making the t-step smaller. So I'm going to make the t-step 0.01 and just see what this graph looks like. So now I can see that this goes from left to right. One other way to explore might be to look at the table. So I'm going to set up this table. And let's see, I guess I will start with a table of -1, even though this is going to go outside the zone of my t value. When I go to look at the table now, I'm given a table of values, right? So t values and the consequential x and y values. The other thing that we could do here, if we go to second calc, so if we look at what is available for us, a lot of this you don't know, right? dy dx is the slope of, in this case, the slope of the line. dy dt is the rate at which y changes with regard to t. dx dt, again, that's the derivative. But the one thing we could look at is the value. So let's select that. And if I want to see the value at t is equal to 0, I can just plug that in, and that's going to give me, going to locate that particular point.